Hey everybody, welcome to another Khan support video. This one is on rates and proportional relationships. So let's go. So it says here the unit rate of change of y with respect to x is the amount y changes for a change of 1 unit in x. Okay, so when they say y with respect to x, they basically mean the ratio of y over x. All right, so that means how much y changes for every 1 change in x. So when it says with respect to x, they're saying y per x, right? For every y per x. The table below represents a proportional relationship with a constant unit rate of change of y with respect to x, of y per x, okay? Which describes a greater unit rate of change of y with respect to x. The equation y equals 7.6x or the table. So what we can see here is that in this table, the ratio of y over x is 8. So y over x is 8 over 1, 16 over 2, 24 over 3, 32 over 4. All that boils down to 8. So this is 8 y's for every 1x, basically. In this situation, it would be 7.6 y's for every 1x. This is which describes a greater unit rate, and that means that the table is going to be a greater unit rate, and then the equation is going to be a lesser unit rate, right? Because this one will be y equals 8x, whereas this one is y equals 7.6x. So which one decides a greater unit rate? You'd say the table. Bamboo is one of the fastest growing plants. A typical growth rate for bamboo in temperate climates is 3 to 10 centimeters per day during the growth season. Which of the following equations, where t represents time in days and L represents length in centimeters, could be the description of the growth of a bamboo plant? So basically, t is time and L is the length. So you're going to input time and output length. So it's going to be some constant times the time equals the length. So that's what you can see here. Some constant times the time equals the length, right? And it says the typical growth rate for bamboo in temperate climates is 3 to 10 centimeters per day. Okay, I'm assuming that's 3 to 10, but it could be 3/10. I think it's 3 to 10. All right, so it says which of the following equations could be a description of the growth of a bamboo plant? Okay, yeah, so it's 3 to 10. So basically, you're looking at any growth rate that's between 3 and 10. So 1.1 is too small, 2.5 is too small, 7.1 is fine, and 9.3 is fine. So it would be C and D because they're between 3 and 10 as multipliers. Okay, Raquel takes her pulse in order to determine her resting heart rate, measured in beats per minute, BPM. She takes it for 3 minutes and makes the following table of the results. We'll assume that Raquel's heart rate is constant over the 3-minute period. The graph below shows an ideal resting heart rate for someone Raquel's height, weight, and age, and a general level of fitness. The x-coordinate represents minutes, and the y-coordinate represents beats. Okay, so basically, in the ratio of y over x would be beats per minute. So it says choose one answer. Is Raquel's heart rate faster or slower than the ideal heart rate shown on the graph? So this is your ideal heart rate, and this is her heart rate. And her heart rate is 62 beats per minute because beats is 62, the minutes is 1, and the beats is 124, the minutes is 2, and so on and so forth. So this is 62 beats per minute for all 3 minutes. So this is Raquel. The question is, which of these is faster, right? So is Raquel's heart rate faster or slower than the ideal heart rate shown on the graph? Well, let's look at the heart rate on the graph. So you want to follow the line. You want to see where you have a perfect identifiable point. It looks like right there you got a perfect identifiable point. And that shows you that when x is 2, y is 140. So in this case, it would be 2 minutes is 140 beats, or 140 beats divided by 2, so 70 beats per minute. So that means that this is a 70 right here. So that would be 70. That looks like it's about right. So the unit rate here would be 70 beats per minute for the ideal situation. And hers is 62 beats per minute. So hers is slower than the ideal there. So Raquel's heart rate is slower because hers is 62 beats per minute, whereas the ideal is 70 beats per minute. Okay, Roberto is having his house painted. The job takes 3 days, and he pays the painter the same hourly rate every day. The cost of the job is in the chart below. which of the following equations, where H represents hours worked and P represents the amount paid in dollars, represents an hourly pay rate that is greater than the painter's hourly rate? So basically, we're looking at the rate of H being input, or X, the P being output, or dollars. So we're looking at dollars per hour as the ratio of Y over X. So in this case, on day one, he got $300 in 5 hours, which is $60 per hour, because 300 divided by 5 is 60. On day two, he got 240 divided by 4, which is $60 per hour. And the same thing on day three. So basically, for all these days, he's paying at a constant rate, and his constant rate was $60 per hour. So which equation would be the correct equation here? Well, basically, your multiplier is 60, right? So it would be the number of hours worked times 60 equals the amount of dollars that he gets. Okay? So it says, which of the following equations, where H represents hours worked and P represents the amount paid in dollars, represents the hourly pay rate that is greater, greater than the painter's hourly rate? So he gets $60 per hour. Which of these is greater than $60 per hour? So this is 50, this is 6.5. Those are obviously less than, right? Because your multiplier here is $6.5 per hour. The multiplier here is $50 per hour. Those are smaller. So the ones that are greater are 65 and 70, because those rates are going to be paid higher than this guy's getting paid. All right. When the peregrine falcons, I can't see very well. The peregrine falcon is in the dive. It can reach speeds of 242 miles per hour, making it the fastest member of the animal kingdom. The graph below shows a proportional relationship between distance and time. How does the speed, miles per hour, represented by this relationship, compared to that of the peregrine falcon? Okay. So this graph here, miles per hour, if we follow the line, we can look for an identifiable point. It looks like right there. This is at 200 miles every 1 hour. So the unit rate of this graph is 200 miles per hour, right? So the peregrine falcon is 242 miles per hour, which is faster. So the speed represented by the graph is less than the speed of the peregrine falcon. That is true. All right, the unit rate of change of y with respect to x, and there's y over x, or y for every 1x, is the amount y changes for a change of 1 unit of x. Is the unit rate of change of y with respect to x greater in the equation y equals 0.25x or in the graph below? Well, this is 0.25x as a multiplier, which basically means 0.25 is your unit rate, which is 1/4. So what this is telling you is that the ratio of y over x is 1/4, or when y is 1, x is 4. All right. So when we look at the graph, we're looking when x is 4, y is 1. It's kind of hard to see, but it looks like this red line is a little bit below that, right? If the unit rate of 1/4 or 0.25 would be right there on that little intersection where when x is 4, y is 1. And so this is a little bit below that. Okay. So it says here, is the unit rate of change y with respect to x greater in the equation or in the graph below? And it's going to be greater in the equation. All right, the unit rate of change of y with respect to x is the amount y changes for the change of 1 unit in x. The table below represents a proportional relationship with a constant unit rate of change of y with respect to x, which describes a greater unit rate of change y with respect to x. The equation y equals 0.25x or the table. Well, this one's going to be 0.4 for every 1. And this one's going to be 0.25 for every 1. Well, 0.4 is greater than 0.25, right? So the table is going to have a higher unit rate. This equation for the table will be y equals 0.4x, whereas this equation is y equals 0.25x. So it says which describes a greater unit rate? The greater would be the table. And that's how you do those problems. Okay.